Here we have a pre-calculus problem on trigonometry. Okay, let's go to the question. Find sine 2 theta, cosine 2 theta, tangent 2 theta. Given cosine theta equals to negative 12 over 13 and sine theta is greater than 0. So here the value of cosine theta is negative and the value of sine theta is positive, that is greater than 0. So whenever cosine is negative and sine is positive, so then the terminal side of the angle measure theta is in second quadrant. Okay, let me draw the four quadrants over here. So it's 0, 90 degree, and here we have 180 degree, and here we have 270 degree, and we have 360 degree at the same position of 0 degree. Okay, from 0 to 90 we have the first quadrant, and from 90 to 180 we have the second quadrant, and from 180 to 270 we have the third quadrant, and from 270 to 360 we have fourth quadrant. Okay, so usually we have to consider the stuff A, S, T, C. A means first quadrant, and S means second quadrant, and T means third quadrant, and C means fourth quadrant. That means like we have the alphabet A for the first quadrant. That means all trigonometric ratios are positive in the first quadrant. Okay, for second quadrant we have the letter S. S means in second quadrant sine theta and its reciprocal cosecant. Only these two trigonometric ratios are positive. The rest are negative. Rest means tangent, cotangent, cosine, secant are negative. So for third quadrant we have T, that means only tangent and cotangent are positive in third quadrant, the rest are negative. And for the fourth quadrant we have C. C means cosine and its reciprocal secant. Only these two trigonometric ratios are positive in the fourth quadrant. Anyways, we have to consider the quadrant where the sine theta is positive. So sine theta is positive in the first quadrant because in the first quadrant all trigonometric ratios are positive. Okay, so sine theta is positive in the first quadrant and the second quadrant as well. But here the cosine theta is negative. So cosine theta is negative means definitely the angle measure cannot be in the first quadrant, because in the first quadrant everything is positive, so cosine also must be positive. But here the given value of cosine is negative, but sine has to be positive, means we have to consider the terminal side of this angle measure theta in the second quadrant. Okay, so now to solve this kind of problems, what I need to do is I have to draw a right triangle in which we have the terminal side of the given angle measure. When I draw a right triangle in the quadrant in which we have the terminal side, always one of the legs of the right triangle must be on the horizontal axis. So here now we have decided that the angle measure theta is in the second quadrant. I mean the terminal side of this angle measure theta is in the second quadrant. So now I have to draw a right triangle in the second quadrant. So when I draw a right triangle in the second quadrant, so one of the legs of the right triangle must be along the horizontal axis over here. Okay, now let me draw a right triangle over here in the second quadrant. So I've drawn a right triangle over here, and particularly this leg is along the horizontal axis. Okay, now we can take the angle measure, given angle measure theta over here. So when you take the given angle measure theta over here, what is the name of this side? This is opposite side. And already we know that the side which is opposite to the right angle is called hypotenuse. And what is the name of the third side? It is adjacent. Okay, according to Sacchetto, so cosine theta is equal to, what's the formula for cosine theta according to Sacchetto? That is SOHCAH and TOA. So here the middle three letters represent the formula for cosine theta, that is cosine theta is equal to adjacent over hypotenuse. So here the given cosine theta can be taken as cosine theta is equal to, this negative sign can be taken along with this 12, then I am getting negative 12 over 13. So here it is equal to adjacent over hypotenuse according to Sacchetto. So the adjacent side is negative 12 and the hypotenuse is 13. Okay, let's mark it over here. So adjacent is negative 12 and hypotenuse is 13. Okay, to get the value of sine theta, what do we have to do? So to get the value of sine theta, according to Sacchetto, the formula for sine theta is opposite over hypotenuse. Okay, so we need opposite side. Already we know the hypotenuse, that is 13. Okay, to get the length of opposite side, we have to use a Pythagorean theorem. Okay, now we can assume the length of the opposite side as y. So then we have y square positive negative 12 the whole square equals to 13 square. So in a right triangle, when I take the square of the two legs, so the sum of the squares of the two legs must be equal to the square of the hypotenuse. This is said by Pythagorean theorem. So I just use the Pythagorean theorem. I have taken square for the opposite side, I have taken square for the adjacent side, and I have added them on the left side. So it must result the square of the hypotenuse. Okay, now let's solve for y, which represents the opposite side. So y square, when I take the square for negative 12, it will become positive 144, and 13 square is 169. Okay, our aim is to solve for y. So let's subtract 144 from both sides. When I do so, this positive 144, negative 144 will cancel out. I'm getting y square is equal to, when I subtract 144 from 169, I'm getting 25. So y square is equal to, this 25 can be written as y square. Okay, now two terms are equal with the same exponent. So whenever two terms are equal to the same exponent, we can equate the bases, then we get y equals to 5. So that is the opposite side is just 5. Okay, now I got the length of the opposite side. So opposite side, we can plug in the length of, the value we have for opposite side, that is 5. And for hypotenuse, we have 13. So now I got the value of sine theta, that is 5 over 13. Okay, so now our aim is to find the value of sine 2 theta. So there is a formula we have for sine 2 theta, that is sine 2 theta equals to 2 times sine theta times cosine theta. Okay, 2 times. This is a formula we have for sine 2 theta. So 2 times, already we got the value of sine theta, which is 5 over 13. And for cosine theta, we have the value in the question itself, that is negative 12 over 13. So when I multiply, 2 times 5 is 10. 10 times negative 12 will be negative 120 over 13 times 13 will be 169. So now I got the value of sine 2 theta. So the value of sine 2 theta is equal to negative 120 over 169. Okay, now let's find the value of cosine 2 theta. There is a formula for cosine 2 theta. That is cosine 2 theta is equal to cosine square theta negative sine square theta. Okay, the value of cosine theta is given in the question itself, that is negative 12 over 13. So we can plug in negative 12 over 13 for this cosine theta. So then I'm getting negative 12 over 13. Since we have square for this cosine, we can square this value negative. And for sine theta, already we got the value, that is 5 over 13. We can plug in this 5 over 13 for the sine theta. So then we get 5 over 13. And since we have square for this sine, we have to square this value. Okay, here, so we have square, and inside the parenthesis we have negative sign. Okay, so the exponent over here is applicable for all the stuff inside the parenthesis. Whenever we apply even exponent for negative sign, it will become positive. So because when I apply this square for this negative, I would write negative 2 times and multiply. So negative times negative will become positive. So whenever I take even exponent for a negative sign, it will become positive. So it will become, this negative will become positive. So now we have square for this fraction. So whenever we have an exponent for a fraction, that exponent should be taken separately for the numerator and separately for the denominator. So when I do so, I'll be getting, when I take this square for this 12, it will become 12 square. The value of 12 square is 144. And when I take square for 13, it will become 169 negative. The same thing, when I take square for this 5, it will become 25. And when I take square for this 13, it will become 169. So now we have a common denominator 169. So we have to subtract the numerators 144 negative 25. 144 minus 25 equals to 119 over 169. So this is the value of cosine 2 theta. Okay, now I got the value of sine 2 theta, and also I got the value of cosine 2 theta. So I have completed 2 parts of the problem, sine 2 theta and cosine 2 theta. So now I have to complete the third part, that is I have to find the value of tangent 2 theta. Okay, so using the value of sine 2 theta, that is negative 120 over 169, and the cosine 2 theta, that is 119 over 169, I'll be able to get the value of tangent 2 theta. So let me write the formula for tangent 2 theta. Okay, the formula for tangent 2 theta is equal to sine 2 theta over cosine 2 theta. So the value of sine 2 theta is 120 over 169. The value of cosine 2 theta is 119 over 169. Okay, now so whenever we divide two fractions, so we have to take the fraction in numerator as it is, that is negative 120 over 169, and I have to change this division as multiplication, and I have to take reciprocal for the fraction in denominator. So when I take reciprocal for this one, I'm getting 169 over 119. This 169 will cancel out. I'm getting negative 120 over 119. So this is the value of tangent 2 theta. So I got the value of sine 2 theta, that is negative 120 over 169, and the value of cosine 2 theta, that is 119 over 169, and the tangent 2 theta, its value is negative 120 over 119.